Hello, this is Mr. Collier, and today we're doing a chi-squared goodness of fit test for a binomial distribution. Okay, so here we have a coin is tossed 3 times, and we're looking at the probabilities of 0 heads, 1 head, 2 head, 3 head. These are the observed values, what is recorded, and we're going to do a chi-squared goodness of fit test to see if this follows a binomial distribution, which it should if it's a fair coin. Okay, so this is a binomial distribution of 3, 0.5, and we can type this in our calculator to get the expected frequencies. Okay, so let's do that on our HP prime calculator. You can do all 4 of them, all 4 of these at one time in the app, the function app. So you can do binomial 3, 0.5, and then do x. So then it'll do 0, 1, 2, 3 for you. And there are 200 coin tosses, so you multiply by 200. Then the data values will pop up under num. If you get a bunch of decimals there, you can always go to shift num to do the setup and make sure it starts at something like 0. Make sure it goes up in 1 and not a decimal, and then go back to num. And you will see, so these are our expected values. 25, 75, 75, 25, 25, 75, 75, 25. We could have also used the probabilities, which, and then do the probability test, but that's okay. You can use the expected frequency. So we have the expected values, and now it's just a matter of typing this into our calculator. We go to Apps, Inference, Goodness of fit, count. If you use the probabilities, you can click on probabilities. But make sure the probabilities are not rounded because they have to add up to 1. But I'm going to type in these values. So then we go to num, and we type in the frequencies and then the expected frequencies. So I'm going to clear this first and type in them very carefully so I don't make a mistake. Okay, they're all in there. Double check that they're correct. And then you can simply click calc, and it gives you a chi-squared value and a p-value. In this case, we have a significance level. I don't think we have we have the critical value down here. So you can use either. With the chi-squared value, it is 2.43. Okay, which is smaller than the critical value. Always compare the chi-squared with the critical value. The p-value is 0.489, which is large. It's bigger than the significance level. Okay, and when chi is high or p is low, we reject HO. So this p-value here is not low, so we do not reject the null hypothesis. We do not have sufficient evidence to reject the null hypothesis. That means the coin tosses do follow the binomial distribution. What was it? B3, 0.5. I think I just remembered we didn't write down the null and alternative hypothesis. That is the first thing you should do. So I should have done that from the beginning. Maybe I'll do that right here. It should be before the test statistic. So we should have started with this. The null hypothesis is that did I say, yeah, coin flips, coin tosses, coin flips. The coin flips, the coin flips satisfy a binomial distribution. Okay, with 3, 0.5. And the alternative hypothesis is the coin flips do not satisfy a binomial distribution and write the same thing. So don't forget to do this first, and then do the test, and then the conclusion. That's the order it should go in.